In this next part of the presentation, we're going to look at interval estimation for P1 minus P2. Now, just first off, interval estimation, computing an interval estimate, that essentially means computing a confidence interval. Okay. P1 minus P2, previously I would have stated that as pi1 minus pi2. The reason I'm using P1 minus P2 is I just find it I find it easier to sort of get those onto the presentation. So I've just decided to use P1 minus P2 this time. And that is population proportions of two samples. So population proportions. Okay. Now, Market Research Associates is conducting research to evaluate the effectiveness of a client's new advertising campaign. Before the campaign, a telephone survey of 150 households. Let's just draw a line under that. Anytime we see a number, just make a note of it. In the test market, show that 60 households, again, let's underline that, are aware of the client's product. The new campaign was initiated with TV and advertisements running for 3 weeks. A survey conducted immediately after the campaign showed that 120 out of 250 households, 120 out of 250, were aware of the client's product. Does the data support the position that the advertising campaign has provided an increased awareness of the client's product? Well, okay, let's just gather up all the information we have. So P1 is proportion of the population of households aware of the product after the new campaign. So that's how we're sort of differentiating the two populations, before and after. Now, obviously, some households are in the same in both populations, but it's the difference is the time period. Now, P2, proportion of the population of households aware of the product before the campaign. Okay, so that's P1 and P2, before and after. Okay. Now, P bar 1 is the sample proportion aware of the product after the campaign. P bar 2, sample proportion of households aware of the product before the campaign. So, okay, remember in the first instance we had the before the campaign. I'm just going to write A for after, B minus before, and 60 over 120. So we had 60 households over 150. This here is P bar 2, and in this after the campaign it was 120 households over 250. This is the stuff I said to underline basically. Okay, now that's a bit of calculator work. 120 divided by 250, that would give us an answer of 0.48. Oops. There we go. And 60 divided by 150, that's 0.40. Okay. So the thing we are interested in is the difference between these two numbers. How much of an increase was there? And this was the difference. At 0.8, 8% essentially. That's their estimated increase. So we have that. By the way, that as a remark, that is our point estimate. Before I continue, point estimate is 0.8. Sorry, 0.08. Now, so that's the first part. Now, point estimate. The general construction of a confidence interval is point estimate. I'll write it down here. Plus or minus quantile by standard error. Okay. Now, we're dealing with a 95% confidence interval. And in that case, let's just 90, that doesn't look like a 5. Hang on a sec, let's do that again. 95% confidence interval. The quantile for a 95% confidence interval when you're dealing with large samples is 1.96. Hopefully at this stage you should be very well aware of that by now. 1.96. So here we have the point estimate. Again, 0.8. Here we have our quantile, 1.96. And the last part is the standard error. So, how do we compute the standard error? Well, essentially what we do is this. So we have it comes from the formula sheet. You should have a formula sheet here, or other than that you have to memorize all of these. The standard error is computed as follows. Hang on, I just got a pen working again. The square root of P1 times 1 minus P1, or P bar 1. So the first estimate, the estimate for the first population, the sample proportion for the first population by 1 minus the sample proportion for the second population. You sort of see that this number and this number are complements. So these numbers are complements of each other. Likewise, 0.4 and 0.6, all divided by n1 plus, I'm just going to continue it on here, P2 by 1 minus P bar 2 divided by 1 minus P bar 2 all over N2. Okay, so I've sort of written it over 2 lines. So when we put in the numbers 0.48 and 0.50, this is what we get. Now this is just a bit of calculator work I've to do that. So once you worked it out, you should find that the answer is 0.0510. Multiply that by 1.96, you get an answer of 0.10. Now, so altogether, the values are the confidence interval goes from minus 0.2, minus 0.02 to plus 0.18. Okay. So that is the confidence interval. Now, just as a quick remark, that indicates that essentially that there's a potential for no increase at all in the context of increased awareness. In fact, it sort of allows for the possibility of decreased awareness, which is not an encouraging sign. Alright, that ends this presentation.